This is a Stellarium tutorial video on predicting eclipses based on the cycles of the moon. Now I've set up Stellarium for April 4th, 2015, and there's a lunar eclipse in progress. It's terrifying. There's a dragon eating the moon. It's turned blood red. Actually, that's not so obvious because I have the moon scaled up. This is that feature that we use to make it easier to see the phase of the moon. So I'm going to turn that feature off. So unscale moon, just show me it's the correct size. And if I hit the space bar, I can keep the moon centered in the field of view, and I'll zoom in a bit. There you see that eclipse. Now the moon is not quite in the center of the Earth's shadow, but it is completely in the umbra of the shadow, so we do have a total lunar eclipse going on. If I run time forward a little bit, let's go a little bit faster here. So we'll see the moon come out of the shadow, and there you see what it would look like as a uneclipsed full moon. I'm going to go back though into the depths of that terrifying eclipse. So go back through the penumbra. There we go, and then back into the deepest part of the eclipse. Stellarium tries to show how the stars will be dimmed due to the light pollution of the full moon, and so the stars come out when the moon is eclipsed more. I'm not sure how realistic that actually is. Now, as an ancient astronomer, this is a terrifying event, and I'd like to be able to predict it if at all possible, so that I have a little bit more warning. Maybe I can make the appropriate sacrifice or go out and bang some pots together, and I won't be so terrified. So practicing science, what I need to do is collect all the information I can about when these eclipses happen and look and see if I have any pattern. And then once I see a pattern, I could perhaps come up with a theory about what's causing this and test it. So maybe one thing that I noticed is that the moon is only eclipsed, is only potentially eclipsed when it's full. So I never see the moon disappear and turn blood red when it's a quarter moon or a crescent moon or anything like that. What if there could be an eclipse at the next full moon? Well, how am I going to find the next full moon? Well, I could step forward a day at a time. So here we are on April 5th. And then April 6th, there it disappeared below the horizon. I could go later in the evening and bring it above the horizon, but I'm just going to cheat and hide the horizon here so I don't have to worry about the Earth getting in the way. The next day and so forth, I'm just stepping around through the lunar cycle. There's a new moon. Sometimes you get a solar eclipse 2 weeks after a lunar eclipse, but it doesn't look like the moon is getting close to the sun there when it's new. There's crescent moon, first quarter, and here I am getting close to, oops, I moved off the moon. Let me get the moon centered again. Here I'm close to full moon, and you see I'm at 99.6% illuminated. If I can get that a little bit closer to 100%, maybe I need to change my time a little bit. That looks as close as I can get. I'm not going to get quite to 100%. Now, I don't have an eclipse, and I know using modern astronomy that that's because the moon is full, but it's not on the ecliptic. So if I turn on the ecliptic in the sky, there's where it is right there. I'm also going to change my orientation so that I'm in that equatorial mode so that I don't have to worry about the local horizon and how the moon is rotating relative to the local horizon. So there's the ecliptic. The moon is not on the ecliptic. If I show the moon's orbit, you can see, yeah, it was that crossing point is way over here. And in modern astronomy, I know that in order to have an eclipse, I have to have the moon on the ecliptic, and it has to have the right phase of full moon for a lunar eclipse. So I could keep stepping through looking for this pattern, looking for the next full moon that might be eclipsed. It'd be nice if I could just jump ahead to the next full moon. Now I know on average the time between full moons is 29.5 days. So I could go over to my date and time control window here, and I could add 29 days and then 12 hours of time. Or I could say add 29 days, find the full moon, add 30 days, find the full moon, as we did with the calendar exercise. Another option is I could use the Julian date calendar. So remember, Julian date is just a number of days counted off since January 1st, 4712 BC, an arbitrary starting point. So I could just take this number, add 29 and a half days, and I should be one lunar cycle, one cycle of phases ahead. But there's a nice shortcut in Stellarium. If you go down here to the help window, by default it brings up the keyboard shortcuts. And if I go to edit keyboard shortcuts, one of the options is I can set a keystroke to add or subtract these units of time. So you see here, subtract one synodic month, and then further up in the window, there's an option to add one synodic month. So I have just, this is not set by default, but I added this keystroke on my Mac. That's Option, Command, right square bracket to jump ahead, one synodic month, and Option, Command, left square bracket to jump back one synodic month. So that's just going to make my eclipse hunting a little bit easier. So I already went ahead 1 month. That was, now I'm May 3rd, 2015, and I don't see a lunar eclipse. So let's keep stepping forward. I'm going to use that keystroke. So there's one synodic month. Notice the moon got a little bigger. We've gone one cycle of phases, but where we are in the orbit is a point that's closer to perigee. The moon's a little bit closer. It can change in angular size by a factor of about 10%, depending on where it is in its orbit. So that's June 2nd, 2015. Another month, that's July 2nd, 2015. Am I on still the month? Let me get that closer. Now, this is 29 and a half days on average, but in reality, the moon could be a little bit faster, a little bit slow. So if you're looking at just one time through the cycle, you could be a little bit off. It looks like I have to go ahead a little bit to get that as big as possible. 99 point. Well, I think I was actually pretty close to the maximum phase. You see, phase is 1.0, illumination 99.7. I'm not going to get it right at 100% this time through because it can't be exactly 180 degrees around unless it's on the ecliptic. And where's the ecliptic in this part of the cycle? Let's see. Oh, there's the Milky Way. You can actually see what's the tilt of the Milky Way relative to the equatorial plane. You wouldn't be able to see the Milky Way with the full moon out like that, but that's okay. So where's the ecliptic? Boy, it's not even... Oh, there it is, way down there. So that's actually kind of an extreme. That's 8 or 10 lunar diameters away. So that's almost as far as it can get from the ecliptic, 5 degrees above or below the ecliptic. So definitely no lunar eclipse on July 1st, 2015. Okay, jump ahead another cycle. There we are, July 31st. So that was actually a month with a blue moon. Colloquially, a blue moon is when you have a full moon on the 2 full moons in 1 month, 1 calendar month. That can only happen if you have a month with 31 days and you have a full moon on the first day of the month. Then 30 days later, you have another full moon. So that's a blue moon. How far have we gone? 4 cycles, I think. So there's 5. That's August 29th. And then there's 6 cycles. September 28th, 2015. You see them a little bit off again, 99.5. So let's try and find exactly when the full moon happens. See, we'll go back a little bit. 99.8, 99.9, 100%. Oh, look, there's an eclipse. In fact, this date, September 27th, 2015, 10:30 Eastern Standard Time. This was that blood moon eclipse that we got end of September in 2015. It wasn't just a total lunar eclipse, but it was also a supermoon. So the moon was close to perigee at the time, so it had a bigger angular size than average. Cool. So 6 months later, I found another eclipse. Now, this may or may not be visible from the same location. So if I were an ancient astronomer, I might not see this eclipse and notice, hey, 6 months later, another eclipse. But let's pretend I did, and so I'm thinking, okay, lunar eclipse every 6 months. Cool. Let's jump ahead another 6 months and see if we get another eclipse. So I'm going to jump ahead using my keystrokes. So 1, 2, 3, 4, 5, 6 cycles through. I'm at 100%. That's exactly a full moon. I don't see an eclipse. I could go fishing, a few hours ahead and a few hours behind. I don't see an eclipse, even a partial eclipse there. But the moon's full, and it's on the eclipse. Well, no, it's not quite full, 99.8. It's just enough off of the full phase. And then when I'm right at the full phase, it's just enough off the ecliptic that I don't get a lunar eclipse. I bet the Earth's shadow is right about there or so, maybe even right about there. So my prediction has failed. So what's the problem? Well, what's happened is I found part of a cycle, but not a complete cycle. And if I look at the eclipse table, you can see what happened here. So let's find that April eclipse. So it's in 2015. This is a chart of all lunar and solar eclipses from 2000 to 2030 almost. And the month the eclipse happens is on the y-axis, and the year the eclipse happens is on the x-axis. So this gray band is 2000, 2005, 2010, and so forth. So my eclipse was in 2015. It was in April. There it is right there, lunar eclipse of April 4th, 2015. And then 6 months later, I got the next lunar eclipse on September 28th, 2015. It was the 28th Universal Time, 27th Eastern Standard Time. And then 6 months after that, I don't have a comparable, that would be in 2016. I don't have a comparable lunar eclipse in there. I've got a partial lunar eclipse 7 months after, and that is, let's see, where'd it go? March 23rd, 2016. Oh no, that's 12 months after. That's 12 months after. Is it March? Do I have March 23rd in my calendar? Yeah, I do. So there's March 23rd. So there may be a bit of a penumbral eclipse, a very slight partial eclipse, but I'm definitely not getting it. I'm not noticing it here in my simulator. In fact, the blood moon eclipse was the fourth in a sequence of total lunar eclipses that happened 6 lunar months apart. It's called a tetrad. So here is the blood moon eclipse on September 28th, 2015. If I go back 6 months, there's another total lunar eclipse on April 4th, 2015. If I go back another 6 months, there's another total lunar eclipse October 8th, 2014. Back 4 months before that, 6 months before that, and we have a total lunar eclipse on April 15th, 2014. If I go back 6 months before that, I only get a partial or penumbral eclipse when the moon doesn't even touch the umbra of the Earth. So you may or may not notice that the moon just dims a tiny amount. So what's happening is that the moon is drifting through the line of nodes at those 4 full moons that are 6 months apart. So that happens pretty rarely. If we actually look to see when do those cycles get in sync, we can actually predict how often that happens. But back to my eclipse prediction, my 6 months prediction didn't work. So what's my next alternative? Well, I just have to keep collecting data. And if I could actually see all of these eclipses, I would say, oh yeah, there's definitely a pattern where the lunar eclipses tend to be 6 months apart, but sometimes here's one that's only 1 month apart. So I get a lunar eclipse, and then a solar eclipse, and then a lunar eclipse. That's fairly uncommon, but you can see where there are 3 in a row like that in 1 year. There's another sequence right there. Lunar eclipses are a little bit more frequent than solar eclipses just because of the tolerance for the moon going into the Earth's shadow. It's a little bit looser than the moon overlapping with the sun and getting a solar eclipse. Now, getting all of this data is going to be difficult for an ancient astronomer who can't travel very far because a lot of these eclipses are going to be on the wrong side of the Earth, or who knows, it could be cloudy, so I might not catch them all. I have to watch for a long period of time before I started to see this sequence. Now, of course, in modern astronomy, we understand that what has to happen for a lunar eclipse to occur is that the moon has to be full, so it's opposite the sun, and it has to be on the ecliptic, or at least close to the ecliptic, so that it's in the Earth's shadow. So the orbit of the moon, if I turn on a line for the orbit of the moon, where the orbit of the moon crosses the orbit of the Earth, there is a point right there. We call that the node, the line of node. So I showed this, let's see, this slide here in class. You see the ecliptic is here, right here, the sun's path on the ecliptic, and then the moon's orbit is tilted 5 degrees relative to that. And where those cross, you could potentially have an eclipse because the Earth, the sun, and the moon could be in a straight line. So for a lunar eclipse, the sun might be over in this direction and the moon could be right there. So the moon's going to go around the celestial sphere and come back to the same place relative to the node once per draconic month. How long does that take? Let's actually see that in Stellarium. I want to get the moon close to that point right there, so it looks like I need to go back in time a little bit. Let's go back one day. That's too far. Let's go forward a couple of hours. All right, it's moving around because of the parallax. Okay, that's actually fairly good. So you see the moon is close to the node. If only it were exactly full, we get an eclipse, but no dice this time. How long is it going to take the moon to go around its orbit and come back to that same point? Let's count the days. So we'll step forward. I'll bring up the control window so you can see that here. So we'll step forward 1, 2, 3, 4, 5, 6, 7, 8, 9. There you see we're far from the ecliptic. 10, 11, 12, 13, 14. There's one of the other nodes. That's the descending node. The other one is the ascending node. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and a little bit more. So it's a little bit more than 27 days to come back to line up exactly on that. Now you might think it should be exactly the same as the orbit, but the problem is that this line in space is not fixed. It also moves around the celestial sphere. It precesses around very slowly. It goes around once per 18.6 years, which affects when you would see the moon at extremes of declination. But we'll talk more about that a little bit later on. So I've got 2 cycles that have to be in sync. I have to go an integer number of synodic months. Let me get back to a full moon here. So we'll go to there. Oops. There's a full moon, close to 100%. And so I can go an integer number of full moons, but I also have to go an integer number of draconic cycles. So I have to wait for 27.2 and 29.5 to get back in sync. Whoops, there's one. I just happened to find one by chance. So that is July 27th, 2018, we get another lunar eclipse. So I could count those out and try and find out when those will be in sync. Since I know what those 2 periods are in days, I could be a little bit more precise about finding out when they will be in sync. So I thought that maybe 6 months would be a cycle in sync. So if I take 6 times a synodic month, that's 177.18, etc. days. And how many draconic months is that? Let's see if that's an integer number of draconic cycles. Well, it's 6.5 and a little more. So it's not 6.5000, or I would be much, much closer to getting an eclipse every cycle. Now, I go around the line of node 6 times and a half every 6 times around the cycle. So I would go from, let's say we have a lunar eclipse here, I go around 6 times and then a half, and I'm back on the line of nodes, but I'm on the other side of the Earth's orbit. You could still have a lunar eclipse, so actually I can go a half of a draconic cycle and still get a potential eclipse. But that's not close enough. What about 12 synodic months? That's pretty close, but still not close enough. So you see, if we go back to the chart, we get, that's basically what these are. So there's a lunar eclipse there, July 7th, 2009. There's one 12 months later, 12 months later, 12 months later, 12 months later. But then 12 months after that, we don't get one. We jump back. So we jump back. It's only 11 synodic months. So we get an eclipse in April 15th, 2014 is going to be the next one. And so you see this cluster of eclipses, 12 lunar months apart, shifts back, because these aren't quite in sync, because it's a little bit too long. Well, I can fish around for integers of synodic months that also give me integer or integer and a half draconic months. These are well known. A good one is 47 synodic months. It doesn't have a name as far as I know, but 47 synodic months is almost the same as 51 draconic cycles. Now, how many years is that? Let's see, it's 1,387.9 days. And I want to know how many years is that. A year is, of course, 365 and a quarter days. So it's 3.8, almost 4 years. So if I have an eclipse, let's find that April eclipse again. So there's April 4th, 2015. If I go 3 years, 0.8, so 1, 2, 3 years over, and then 0.8 down, that's another lunar eclipse. There you see right there. I can actually hunt for that in Stellarium. So let's go back to 2015 and April, and let's find the total eclipse. There it is right there. And let's jump forward. Whoops, go back. There it is. Let's go forward 47 synodic months. Now, I'm going to get impatient stepping forward by 47 keystrokes of my synodic month cycle. So I'm going to use that Julian date trick. So here it's Julian day 2457116.98, etc. It helps if I stop time. It's a little bit easier to put the date in when time is stopped. Okay, so there's the Julian date for the middle of that eclipse. I want to jump forward by 47 synodic months, and I can figure out how many days that is. It's that many days. So I already put in the Julian day number for the April 4th eclipse. So let's just add 47 synodic months. So 47 times SYN. That's the new Julian day number. Now, unfortunately, Stellarium doesn't accept cut and paste from other applications. I guess that's being cross-platform. That's one of the drawbacks. So I got to put this in manually. So 2458504. So 8504 are the 4 digits here. 8504. All right, there we have the correct phase. And actually, I'll just jump back in time here. There we go. There's that total lunar eclipse on January 28th, 2019. So if I jump, it should be 3.8 ahead from this one. So 1, 2, 3, almost 4. Actually, it's this one back here. January 21st, 2019. That's this one right here. Let's see, other cycles. One of the famous ones actually is the Saros cycle. So a Saros cycle is an integer number of synodic months. It's 223 synodic months, 223 cycles of full moons. It's also an integer number of draconic months. It's 242 cycles around the orbit. Just by convenience, it's also an integer number of sidereal months. That's one time around relative to the stars. So the moon comes back to the same place in its orbit. So if you had a supermoon, for example, because the moon was at perigee, when you go around one full Saros cycle, the moon's back at perigee again, and you should have another supermoon eclipse. So it's 223 synodic months, 242 draconic months, and then 241 sidereal months. So if I wanted to find the next eclipse in the Saros, I could take this Julian day for the April 4th eclipse and just add on a Saros, which is that many days. So here's the Julian day number for that next total lunar eclipse in the same Saros family. I suppose we can go look at it. So it's going to be, go to Julian day and put in the number 2463702. So this has got to be 6702. And 2463702, 24, I got a number wrong. 2463702. So 2463702. And again, I'm just going to go back. I can see where the line is there. So this is going to be very similar to placement as that April 4th. And yeah, you can see the umbra is now sort of off to the west and south of the center of the moon, just like it was for that April 4th eclipse that happened in 2015. But now we're 18 years ahead and 11 days ahead compared to where it was before. So that's the Saros cycle. You can see the Saros cycle, 18 years and a little bit more. Now, it's off the edge. 2033 is off the edge of my chart here. But if I pick, say, a different eclipse, let's pick the solar eclipse here. This is a solar eclipse of June 21st, 2001. And you see there it says Saros number 127. Every eclipse has a Saros number. It belongs to that family. And an eclipse that's one Saros cycle ahead or one Saros cycle behind is going to be in that same family. So if we jump ahead 18 years, that's also Saros 127. And that should be a very similar eclipse, but a third of the way around the Earth. And then 18 years ahead would be off the chart over here. So it takes a long time, long period of observations to notice these cycles. But we've known about the Saros cycle since ancient Greek times. And this is how you can potentially predict eclipses. Now, as I said, these cycles are averages. The moon could be a little bit ahead or a little bit behind. But it works really well for a very long cycle because the speeding up and slowing down of the moon averages out over many, many cycles. So the Saros is actually remarkably accurate.